Hey everybody, I wanted to come through and work a couple of these practice problems for you in activity 1.1.2, the simple machines practice problems. A couple things that you're going to need. I just have our formulas here. The IMA, remember, is deer, DE over DR. Ideally, I'm going to kill a deer. And then AMA is not free. And so force resistance, my R is a little small, over force effort. And then we'll also be using our static equilibrium, the moment resistance is equal to the moment of the effort. So thinking about that idea of balance, and if it's statically determinate, and not statically determinate, it's statically balanced. All right. So let's get started here. When I'm doing this with my kids, when we're reading these problems, I like to try to have them think about the knows and need to knows. What are we looking for? And it says a first class lever in static equilibrium. So that's our first class lever. And it's this static equilibrium has a 50, that tells us it's not moving, 50-pound resistance force. So I might just come over here and I might write force resistance is equal to 50 pounds. I can pull that right out. And a 15-pound effort force effort is equal to 15 pounds. The lever's effort force is located 4 feet from the fulcrum. So distance effort is equal to 4 feet. I use the little denotation there for that. So that's, and then it says in this, sketch and annotate the lever system described. So we know it's a first class lever, so that's going to be a cedar seesaw. So I'm just going to draw a seesaw, make my fulcrum. I'm not worried about the scale or anything like that. And I say, okay, I'm just going to decide that this side over here is going to be my force resistance. And so I'm going to say, well, my force resistance I know was 50 pounds. And over here, I'll put my force effort. And we knew it was 15 pounds. And then I got to say, okay, so what is my distance? And we did know that the distance effort is going to be 4 feet. So from this point over here, I drew my little arrows, is 4 feet, and that is my DE. Okay, so I don't know the distance resistance yet, so they're probably going to ask me for that, right? That would be my what do I need to know question. And the first question that asks us, though, is what is our actual mechanical advantage? And so we look up here and we say, what's our AMA? Our formula for that is AMA, actual mechanical advantage, is FR over FE. Then all I got to do is plug and chug. So I come up here and I go, okay, well, what's my FR? Well, it's right here. It's 50. And that's over our FE, which is 15. Well, I plugged it, and I'm going to take my calculator, and I'm going to go 50 divided by 15. It should give us like 3.33 repeating. So over here, I'll just say 3.34. And this cancels that, so there is no unit, remember, for mechanical advantage. So that's the very first one, okay? Now let's go to the next page, and it's still talking about this problem up here. So I'll let me fold that in half, and so we can have it to look at. And it says, using static equilibrium calculations, calculate the length from the fulcrum to the resistance force. And so what it's wanting you to do here is use that formula of the moments being equal. We're going to work this 2 different ways, actually, okay? The first way that I'm going to work this for you is I'm going to do that. I'm going to use the way that they want us to do it. And that is our moment resistance is equal to moment effort. And if we remember that moment is force times distance. So I say force times distance is equal to force times distance. And then on one side would be my resistance, my force resistance, distance resistance. And on the other side would be my force effort and my distance effort, okay? So then it's a simple, once again, a plug and chug, okay? So it's a force resistance, which I can look down here and I can go 50 pounds times distance resistance. That's my X, that's my unknown, is equal to force effort, which is 15 pounds times my distance effort, which is 4 feet, okay? Well, isolate the x, divide both sides by 50, and you can solve down for your answer there. So 15 times 4 is 60. Divided by 50 would give us 1.20 feet. Okay, so now the other way to do that, let me get a piece of paper out that I can write on, is the same way to get to Walmart here is to set, and this is one we talked about in class, AMA equal to IMA. Okay, and so if I think about that, what am I doing? I'm saying distance effort over distance resistance is equal to force resistance over force effort. All I've done is I've taken those and just rearranged them. Now, it's a simple plug and chug here. Distance effort is 4. Distance resistance is my X. Force resistance is 50. And then my force effort is 15. Okay, so 15, so same math, 15 cross multiply, 15 times 4 divided by 50 still gives us 1.2 feet. So I just want to show you 2 different ways to get to Walmart on that. Either way is fine. And that is the very first problem, and I'll make more videos about the next ones. I hope that helps.